everybody, nice to see you again for another amp dyno video. Today's victim of torture testing is the Rockford Fosgate 2.3, which is the smallest amplifier in the 1997 amplifier range. It's 15 watts by 2 into a 4 ohm load and 30 watts by 2 into a 2 ohm load at 0.08% THD. Here is the gain knob. Here you can make your connections for your speakers, left, right, battery plus, remote and ground.
The 2.3 is connected to the load and I start with 8 ohms mono, bridge mono, to test the output power into a 4 ohm load per channel, both channels driven, and I start with 1 kHz. Continuous power test 1 kHz. And we have a peak voltage. It says maximum peak voltage 34.4 volts. We have 34.2 volts. The amplifier is rated 15 watts of continuous power into a 4 ohm load, and I measured 37.5 watts into a 4 ohm load of continuous power with 1 kHz. Here you see the idle current, and now I give also full power to check out how many amps the amplifier pulls out of my power supply, and it's 7.86 amps. The amplifier has a calculated efficiency of 69.8%. If I test with continuous power and with a small amount of dynamic headroom, I'm slightly a little higher than 70%. Continuous power test 50 Hz input signal. It says peak voltage 34.4 volts. Going to confirm this. But we are at 33.8 volts. With a 50 Hz input signal, the amplifier is still able to deliver 36.6 watts of continuous power into a 4 ohm load per channel, both channels driven. Checking for dynamic headroom with 20 cycles and 1 kHz. I'm starting. First cycle says no clip. And it says 34.8 volts. I go down, but we are also at 34.4 on the first cycle. Let's have a look at the average voltage here in the middle. We stay at 34.4 volts. I go to the last. I adjust it to the point clipping occurs. 34.4 volts. There's no dynamic headroom with 20 cycles. Also with 8 cycles we have 34.4 volts. That means we have around almost 38 watts. First test, just 1 cycle. It has some clipping here and there. I'm going to reduce. So that's okay. It's sturdy, but we have a peak voltage of 34.8 volts. So there's almost no dynamic headroom, just 1 watt more. That's ridiculous, so no dynamic headroom. Now I switch to a 4 ohm mono load, bridge mono to the amplifier. Let's start again with 1 kHz. It says 30.8 volts. Go to the top of the waveform. I would say 30.4 volts. In this case, the amplifier delivers 59.25 watts into a 2 ohm load, both channels driven with 1 kHz. The amplifier pulls 13.2 amps. It's surprising the amplifier features a very nice efficiency of 65.8%. Continuous power test with 50 Hz. Let's have a look how much output power there is with 50 Hz. Scope says maximum 29.2 volts. Yeah, I can confirm it. 29.2 volts. The amplifier delivers 54.6 watts into a 2 ohm load per channel, both channels driven with a 50 Hz input signal. Dynamic power test, 1 kHz, 20 cycles. Also 30.4 volts. There's no dynamic headroom with 20 cycles, so I switch directly to 8 milliseconds test. There it is. I check the last cycle. This is some kind of continuous power test because I have a burst, a pause, a burst. Now I go to the last ones. Check for clipping. Now I increase my signal level, but it gets dirty. That means we have also no dynamic headroom. I take a screenshot and it says also 30.4 volts with some distortion, so also no dynamic headroom. Now I'm going to check with just one cycle. I increase signal. If it gets dirty, doesn't. We get some more voltage, but I guess it will go into clipping. Here we have some kind of distortion. Let's take this value. We have 31.6 volts. It's ridiculous. For 1 millisecond and a nice amount of distortion, we get 64 watts out of the amplifier. That's just for demonstration. Because of the nice efficiency of the amplifier, I'm going to do a 2 ohms mono test. Now, 2 1 ohm resistors are connected in series, bridged mono to the amplifier. That means I test 1 ohm per channel. And I will start with continuous power. 1 kilohertz into a 1 ohm load per channel, both channels driven. I start input signal. Amplifier is not overheated. Let's check it out. Oops. Distortion and clipping. I try to fine adjust the input signal, but I get distortion. You see this here? I reduce until it looks great. And now we are free of distortion. Take a screenshot and we have a look at the peak voltage. It says 17.2 volts, 16.6 volts, 16.4 volts. The amp just delivers 33.6 watts into a 1 ohm load per channel, so there's no more output power. Now I go to dynamic burst power test, and I'm sure it will deliver much more output power. That's like testing with music. That's a lighter load for the amplifier's power supply. Dynamic power test with 20 cycles. Checking if all the cycles are at the same voltage level, and that's the case. I take the first cycles and read the top voltage. It's 24.6 volts. And I go to the last cycle as usual. (24.6 volts). All cycles are at the same voltage level. That's nice. The amplifier delivers an output power into 1 ohm of 75.6 watts with a burst of 20 cycles. This test method is the same value you have in your Rockford Fosgate burst sheets. So the amplifier is doing 150 watts, 2 ohms mono. Not bad. Now testing with 8 cycles. I will not expect some more. You also have 24.6, I guess. Yes, 24.6 volts. And testing for 1 cycle. Here we have 1 cycle. This is absolute peak power with some dirty distortion until the amplifier is checking out. The amplifier checks out. Look at this signal behavior. There we have it. And it says maximum voltage 26.8. Let's calculate with 26.6 just for fun. As you can see in my certificate, I tested the amplifier with 13.6 volts. Expect some more watts if tested with 14.4 volts. So in my opinion, this is a nice small amplifier and you can squeeze out around 150 watts if connected 2 ohms mono It did not go into protection. The amplifier limits its output power. Small, nice amplifier made by Rockford Fosgate, I guess in '97.
If you like this video, please leave a thumb, subscribe to the channel and keep watching my next videos. Thanks for watching, see you next time, bye bye.